Okay, so in this module, we'll cover shared storage technologies. Um, we'll start off our discussion with taking a look at our directly attached storage and what are some of the limitations of that, and what we are trying to achieve with shared storage. After that, we'll take a look at the different shared storage technologies that we have. Fiber channel over Ethernet, iSCSI, NFS, vSAN. We'll identify those theoretically in this module. Following this module, then we'll go into the demonstration of setting up our iSCSI and NFS storage. Since I do not have the infrastructure in place, so we could demonstrate fiber channel or fiber channel over Ethernet. Okay. But before we get directly into the shared storage technologies, I would like to let's just take a few minutes and identify our local storage and what are some of the limitations of this. So storage for ESXi hosts, they could come from either a local or some sort of shared storage technologies, which we'll discuss in a bit. So local or directly attached storage, this is where we are utilizing the storage media that is directly on our ESXi host. We are utilizing this local media for installing our ESXi or for storing of our virtual machines. All right. So our directly attached or our local attached storage are generally connected to our ESXi host through some form of connection, for example, a serial attached SCSI, and not over a network connection. Although we can provide some sort of redundancy through RAID, local or directly attached storage would provide a single point of failure. There are some use cases for our directly attached storage though. It may be ideal for situations where cost is a factor, or we don't need to balance our resource utilization or provide a high availability utilizing our vSphere advanced services, things like DRS or HA. Maybe those are some of the technologies we are not running in our infrastructure, and all we need is some means of storing our virtual machines locally on our host. So in that case, directly attached storage would be ideal. Another use case for our directly attached storage is if we want to create a data store for storing non-critical data, like our ISO images. We could store those locally. Images that you could easily gather back. So although we may be using some sort of shared storage technology, we may have our local storage media on our ESXi host providing a storage capacity for ISO images. Okay, so next we have our shared storage. Utilizing shared storage facilitates us the ability to use a central repository for storing our virtual machines and templates. And it also enables us to use some of vSphere advanced features like vMotion, HA, DRS. Those are some of the few that would require us to run some sort of shared storage media. It also allows us to provision large amount of storage for ESXi hosts, since we could have a dedicated storage server that performs basically just storage functions. Also, once we're utilizing shared storage, we can avoid the local storage maintenance factors, since we could have the ability to boot directly off of a LUN on our SAN. So we don't necessarily need to have any storage media directly attached in our ESXi host. So I have a slide here with some of the services that would depend on shared storage technologies. Here we have a couple different shared storage technologies that are available to us in ESXi. We could configure a fiber channel. We could configure fiber channel over Ethernet storage. We could configure iSCSI and NFS storage. For our purposes in this course, we'll be dealing mostly with iSCSI and NFS. We'll demonstrate setting up of this. I'll also take some time to go through how we could set up iSCSI target and our NAS for NFS share. So if you guys want, you could set that up in your lab environment to practice some of the things that we will be demonstrating. So we'll have a separate module where we'll go through setting up these here. So let's move on from here. Let's just recall our virtual machine, all they see for storage are virtual disks attached on a SCSI controller. Okay. And all we're doing when we're utilizing some form of shared storage media is we're encapsulating that SCSI traffic over some connection. All right. So fiber channel, it basically utilizes the fiber channel protocol to move SCSI traffic from our VM to fiber channel SAN. So basically we would have our ESXi host with a host bus adapter. This is a dedicated adapter for fiber channel. So this would connect to our fiber channel switch, which in turn would be connected to our fiber channel SAN. And all of this would be independent of our regular Ethernet network in our ESXi host. Okay, so this would be a dedicated network or connection for storage. The primary disadvantage of implemented fiber channel system would be cost. Since we'll need to procure additional hardware like the fiber channel switch, the specialized host bus adapter in our ESXi host. Okay. Then also our fiber channel system would require optical connection. We could also use copper media for our connections. But basically optical technologies would typically provide a higher bandwidth, a lower latency. So basically we could push upwards of 16 gigabits per second on a fiber channel network. Also, all the different pieces of our fiber channel system, the different pieces including our initiator, targets, and LUNs, they would be identified by a worldwide name. So this is a unique name that would identify all the different pieces within our infrastructure. Next, we have our fiber channel over Ethernet. Okay, so this is where we are encapsulating, or we're taking fiber channel frames and we are encapsulating it to be sent over our regular Ethernet network. Typically, we would use 10 gigs and higher network when we're running fiber channel over Ethernet. And we would require a converged network adapter or a supported network adapter in our ESXi host. The primary disadvantage of fiber channel over Ethernet would be the load that we are placing on our Ethernet network, that additional load, and the cost of our converged network adapters. That's the primary disadvantages. Advantage of our fiber channel over Ethernet is basically we would have a consolidated network to manage rather than managing both a fiber channel fabric and an Ethernet network. Okay. Next in our list here we have our virtual. Okay, so next in our list here we have virtual SAN. This was introduced with vSphere 5.5. And it builds on what used to be called vSphere Storage Appliance, or VSA. This was the old name for it. With 5.5, it was rebranded into Virtual SAN. So vSAN is built directly into our ESXi host, so we don't require any additional software for this. And it allows us to utilize the local storage media in our ESXi host and build a cluster to form a virtual SAN. Alright? So basically, it would allow us to pool our storage resources from the different ESXi hosts to form a data store. And it requires a minimum of 3 ESXi hosts, but it could scale to a maximum of 64 ESXi hosts in vSphere 6.0. So, to aid in the performance, each host that is part of the vSAN would require some sort of solid-state storage media for caching purposes. Alright, so maybe you have a RAID 5 array in each one of your ESXi hosts, but you would also require at least one solid-state disk for caching. What we could do with vSphere 6.0 is also create an all solid-state storage virtual SAN. So all of our media, including those for caching and that would actually store a virtual machine in our ESXi host, all of that could be solid state storage. So let's say we decided to deploy a hybrid solution. So meaning we're utilizing our standard hard disk drive and our solid state for caching. We'll have to keep in mind that the SSD deployed in that host, it would be used only for a caching. So that capacity of your SSD drive, you cannot use that for the storing of your virtual machines or ISO images. So basically, we'll just use the SSD for read and write caching. So when data is written to data would be written to our SSD storage first before it is written to our traditional hard disk drive in that host. Also, what's new in vSAN 6.1 is included support for vSphere fault tolerance. Okay, in the next slide here, I have some requirements for vSAN. So vSAN would require a minimum of 1 gig interfaces in our ESXi host. VMware recommendation is you have 10 gigs interfaces, 10 gigs or above. We would also need at least one SSD or solid state drive. And ideally you would want your storage controller to be a SATA or SAS. And you would want to have those configured in a RAID array. This is basically due to the nature of the data that you would be storing on that host, a virtual machine in this case. Okay, so next what I'll do, I'll just take a couple minutes and go through where we'll configure our virtual SAN. So we'll go on our vSphere web client and just have a look at this. And following that, then we'll get into our discussion on iSCSI. So let me just pull up my vSphere web client here. I do not have the capacity to create a virtual SAN, but we'll go through the different steps that we'll need. Okay. So firstly, you would want to go to your tree host, or let's just take a step back. You would want to ensure firstly that you have solid state storage on all three of your hosts and some sort of hard disk storage capacity too on those hosts. Or you could have in vSphere 6, as I mentioned, we could have an all solid state virtual SAN. Alright. So the first step you would want to do is check on that. Make sure you have your solid state disk in here. Next, what you would want to do is create your VM kernel port for vSAN traffic. So you would do this. Let's just assume this is the tree host we are putting in that cluster for our vSAN. So we'll go in each one of these hosts here. So let's do that. Let's just back up here. ESXi1 manage, then networking. We'd add networking to this host. So what we want to do is add a VM kernel adapter. We could add this on a new vSwitch or select the current vSwitch 0. Okay. So let's just give this a name. Let's call this vSAN. Let's just call this vSAN 1. Okay. If we are using a particular VLAN for this or vSAN traffic, we would enter that here. And at the bottom here, for enabled services, we would want to enable our virtual SAN traffic on this VM kernel port. Okay. We would want to manually set our IP address for this VM kernel port. So I'll just set this to automatic for now, since we're not actually deploying this. Okay, so here is the adapter that we just created, vSAN 1. Okay, so what we'll do is go on each one of our ESXi hosts and create this VM kernel adapter. So on host 2, we'll do the same thing. Host 3, we'll go ahead and do the same. Alright, so once we have this VM kernel port configured on all three of our ESXi hosts, the next thing we'll want to do is to create a cluster. If we don't already have a cluster, if you already have one, we'll edit the settings for that cluster. In that case here, we'll right click the cluster, then go into settings. This is just taking a few seconds here. My system is running near capacity here, so it will respond a bit slow. Okay, so we could come into our virtual SAN setting here. If you go on the general and then edit the setting, we could turn on vSAN. But let's just create a new cluster and see how we could do this from scratch. So we right click our data center and create a new cluster, and let's just call this one cluster 3. Okay, so cluster 3, and we have the option here of enabling or turning on virtual SAN. Okay, and we could set our disk to, or we could automatically add our disk here to storage or manually configure that. So I'm not going to turn this on now. I'm just going to click OK here, so we have our new cluster up and running. So here we have our cluster 3. What we'll want to do next is to go in the settings for cluster 3. So we are at cluster 3 here, manage, and then virtual SAN. If we were to hit edit here, we'll see those same options that we just saw. So we could turn on our virtual SAN here. But before doing this, what you'll want to do is at this point, those 3 hosts that we would have configured our VM kernel port on with the vSAN service enable, we would want to drag those 3 hosts into this cluster. So let's just assume we have our 3 hosts in this cluster. That's when we'll go and turn on virtual SAN, right? So once we have this configured in here, the next step we'll want to do is come under disk management. So we're still under the virtual SAN heading. We'll just come below here into disk management. So if we did actually enable a virtual SAN, we should have the option here of creating a new disk group, the icon here. So once we go through that wizard to create a new disk group, we would add our solid state drive that is present on this ESXi host. On our different ESXi hosts, we'll add the solid state drive for caching. And also we would add our regular hard disk drive that we need for our storage capacity. So we would add those in there too. And once we have that configured, we should see our data store come up with the capacity for that first host that we add the storage for. So let's just say we had 100 gigs of capacity in that first host. Our data store would, our virtual SAN data store would come up with 100 gigs. So then we'll do the same thing for the other hosts. Once we go through that wizard to create additional groups, the capacity from the different hosts would add to that first one that we created. So if we went to the second host now, we would add another 100, and the third host another 100. In the end of that, we would have a data store with 300 gigs of capacity. And once we finish that, that's basically it for virtual SAN. The data store would be shared across all 3 of our hosts there. So it's pretty simple. You create your VM kernel port, you create your cluster, you enable the service in your cluster, you drag your host into your cluster, and then you enable virtual SAN here.